All right, we are not going to get some of the core guys today because they are at the FAST conference out in Oakland. I'll maybe just give folks maybe a minute more here to gather, and then we can get started. I have actually been on PTO for the last couple of weeks, so that is why I haven't been here. And I have to apologize a little bit. I did not make it very well through the backlog of performance pull requests that have been updated over the last couple of weeks. So I'm going to have to finish that up today. But I've got some of it done here, but there's a whole lot of new stuff that I don't have in here. So maybe instead of specifically going through these pull requests right now, I will mention some of the things that have been going on over the last couple of weeks while I've been gone. Radoslav's been making a lot of progress on doing some performance testing on the read side and uncovered a couple of different issues. The big one that he's actually already got a PR merged for was in the hot path we were accessing configuration options through mdconfig-t, and it turns out this is actually really slow. I was actually seeing it in some testing that I was doing as well while I was on PTO. It's pretty bad. So he's actually got a PR in place already that caches or makes it possible to cache these options, and it helps dramatically. It's really good. So that is not only in the read path, but in the test I was doing, it was in the write path as well. We were accessing configuration options regularly inside loops, and it was slow. So that's a big improvement. There has been some other things. There's a PR that I submitted for processing. It was basically we were filling in O streams when not doing debugging. So essentially, we were for the purpose of debugging, filling this stuff in, but it wasn't when we actually had debugging enabled, and it was slow. So this is basically just for when checking whether or not an OSD is full. So the good news here is that it's not too hard to fix, and there's actually I've got a PR for fixing it, and then David's got another PR for fixing it that works just a little bit differently. So hopefully soon we'll have that fixed, and that also should reduce CPU consumption in the OSD at least by a little bit. So those two things were two big things that kind of stood out as low-hanging fruit in the OSD. I guess I'll use this as a kind of a platform then to talk about a thing I was working on while on PTO. I noticed that memstore is actually kind of slow. I think other people have talked about this in the past as well. But it turns out that when I was doing some profiling, the buffer list implementation specifically of objects in memstore is just it's super high overhead. So I started working on making a kind of a new object store playground thing called Pet Store that I just kind of use as a thing to screw around with and try different things. And one of the things I tried there was using vector-based objects rather than bufferless, and that was dramatically faster and actually really easy to implement. It was surprising just kind of how much better it was. So using that and then also applying some of these other performance fixes, it kind of gave a good insight into what the the bottlenecks in the OSD are. And the really big thing that stuck out is pglog. It's pretty high overhead. As an example, removing in, say, the replicated backend, the call to log operation, commenting that out, and then fixing the asserts that get thrown because of it. That lowers on my dev box the CPU consumption of the OSD when using an in-memory vector-based in-memory store. It removes the CPU consumption from like 5 cores down to about 3 cores. This is to get about between like 40 and 50,000 write apps for 4K random writes. So it's really significant. Just doing pglog is not quite half of the CPU consumption. And also when you look at it with BlueStore, pglog updates are really significant in terms of how much work they're making the KV store do. So this is just really reinforced for me personally that kind of in addition to the work that we're looking at for moving over to something like C-Star, we also really need to be looking at pglog and whether or not we can do any of it better. I think the kind of idea of using per PG ring buffers is really good, at least on something like NVMe, where we don't care as much about contiguous writes as we do about just lots of parallelism and reducing the amount of work that we make RocksDB do in terms of kind of just record keeping, and then also maybe the complexity of the pglog code itself. So anyway, that was kind of where I wrapped up with kind of that project. There were some other things. There's a fair amount of encoding and decoding overhead that kind of crops up once you get all this other stuff out of the way for object info T and a couple of other data types. So probably improving that, maybe using the same mechanisms that we did in BlueStore to avoid appends to the buffers is probably good. And then PG info, there was some overhead with that as well. But that's kind of getting more into then the higher hanging fruit, I guess. So yeah, that's kind of what I've got for the past couple of weeks that have been going on. I don't know, Radoslav or Adam, do you guys want to talk a little bit more about some of the things that you guys have been looking at? I think maybe you've done that in some of the other weekly meetings here, but are there any updates that are worth mentioning?
I guess it would be reasonable to talk about some our debugging facilities we have in OSD that are affecting the main path. For instance, we have our own abstraction over mutexes. It's responsible for log depth. It's responsible for counting and providing a lot of our asserts with method called is locked by me. Unfortunately, the implementation, this single debug, I would say, method requires a lot of additional atomic increments, which is painful because requires enhanced instruction. I thought I'm curious what if we could whether we could use some private and very, very ugly but cheap mechanisms that some of the Pfrit implementation offer. for NPTL, there is facility to check to implement the is logged by me very cheaply without additional atomic. However, it's as I said, it's ugly. It's private. It's a member of private structure, and basically we shouldn't do that in our production code. However, in production code, we are affected by debugging facilities, affected by unnecessary atomic increments, unnecessary calls to through PLT to pfread Ceph, etc., etc. Perfectly unnecessary.
Have you? So I know I've seen the presence of mutexes in the wall clock profiling results that I've seen. Are there any specific things that you're targeting, or kind of?
I'm just assuming that such abstractions like common / mutex are very common. So even if we can squeeze tenth really small part of a single percent for each such usage, overall we could get a lot of benefit. What is interesting is when I'm running perf. What is interesting is the difference between mutex, common / mutex, and the pfread call to actually lock the underlying low level mutex, and it can be significant, especially on vstart when logdep is enabled. However, even after disabling it, it's still not zero.
So let's see here. There are some places where I'm seeing it show up. Definitely the sharded op work queue. Then what else here? That's a big one. In the finisher thread so I'm looking at some of the wall clock profiles that I got from Pet Store. In this case, it's just a single finisher thread, but it's still spending like 17% of the finisher thread's time in mutex lock. Although 16.6% of the time, so the majority of that time in mutex lock was spent in pthread mutex lock.
Yep. For this guy, we can't do much, to be honest. The part
right,
we can.
Yes, but you mentioned the atomics, but where are these atomics here?
Let me provide a direct link. 1 second. Okay, got the line. It's on line 19.2. Here is the link.
I did actually see some time spent in post lock, just a tiny bit though. At least in the profile I did, the wall clock profile I did. It wasn't much. Radek, I did, however, see a fair amount of time spent in the perf counters, like you were talking about earlier.
Yep.
I think just based on what I'm seeing here, the perf counters were definitely more impactful, in at least according to these stats, than maybe the locking is.
Yep, those they are enabled by default. The early exit the early exit for the on the config option is deeply buried inside definition in CC file, so no way for compiler to inline. And also, we are doing a lot of calls to Ceph clock now because of perf counters.
Yeah, let's see. Yeah, Ceph clock now and mono clock now both are showing up at least moderately. I imagine that would have a couple % impact based on looking at this. Radek, in your read tests that you've been doing, have you seen much overhead from the MOSD op encode decode functions, or also from the object info T structures?
Nope.
Okay.
Don't think so, but let me re-verify. I have a file from perf record. Sorry, getting back to the mutex. Piotr, you are right. I've confused. I've mislooked. That's actually right. STD mute, our common mutex doesn't do the STD atomic operation. I confuse it with read write lock we have also common RV lock.
Yeah, there is a STD atomic there.
Yep. And moreover, it's turned by default. It's turned on almost for all cases. There is no something like g lock dep to disable those tracking globally. Nope, it's possible only by passing additional parameter on construction. That it seems that most of the users don't do that.
I just posted a link in the Etherpad to the profile that I was looking at here.
Mark, could you please also post the link to Etherpad?
Yes, or to the
Thanks.
chat window here. There we go. Take a look at that. So this is my vector object memory in-memory object store thing. And then the OSD with the log operation ripped out. A call to some of the PG info stuff ripped out. Your MD config T cacher, and then my check full PR that gets rid of the overhead for processing the O stream. So the some of the things there, Radek, that might be interesting are let's see now. I may have made this cut out too much stuff, possibly. Log op stats on line 184. That's exactly the stuff that you were talking about earlier with the counters, the perf counters. Log op stats is almost entirely doing Ceph clock now and perf counter work. I should have maybe made this a little more detailed and gone down into it, but that's exactly what that is. How about do OSD op effects? That might be. Oh, I don't know what that is. I'll have to look at that in more detail later. This. What else? We're spending a lot of time also in the destructors for op request and
op history.
Yeah,
and it's quirky. It definitely can be quirky because we have conditional there based on time. So it could be that profiling affects the results as well. However, I started digging there with perf and some reduced frequencies, sampling frequency, and still some overhead is clearly visible. There are some. First of all, those guys are running locking and unlocking mutexes over and over. There is a call on tracktop called get duration that is called very, very frequently, and unfortunately takes a mutex and makes some comparisons of on last member of STD vector. So remember the reference there. Also, the comparison operator is far away from being optimal. I have some patches that switched from str CMP to equality operator that has early exit based on size mismatch. Unfortunately, we are losing the information about string size because of taking to pointer to C string. I've exchanged that with std string view, and this allowed to remove some repz cmps calls in the code. Also, there is the wall tracker. The op tracker is good candidate to apply tiny vector on it. It's sharded. However, we have two unnecessary memory indirections there, because we are storing pointers to shards on std vector. Completely unnecessary.
Yeah, op request is actually showing up in a couple of places here. The destructor for op request is showing up in a couple of places here. This is
Mark, are you
actually
sure? Are you absolutely sure that the lock dep is disabled on your system? I had some profiling traces with extremely high usage, extremely high rate of CPU burn, CPU cycles burned there because of mutex dance. And the mutex dance is extremely costly when you have log dep enabled, like in all vstarts run without the dash no log dep parameter.
well, I'll have to look.
Yep, all vstarts spawn clusters have log dep turned on.
Okay.
I was really confused yesterday, but really, it's there. Just take a look on your Ceph config. If log dep is there, need to repeat.
Is it enabled by default?
Yep.
This was not used by vstart, so
Okay. In defaults, it's by default it's false. It's disabled. So affected. Its production code is definitely not affected.
okay. Well, this would be a self compile, but still, yeah. A lot. Wow. Boost intrusive pointer. So the destructor for the intrusive pointer for op requests was using like 8%. That's pretty high. Wow. Well, anyway, yeah, that whole area appears to be worth looking at. Op requests in general. There's a lot of stuff here.
Yep. Trying to refactor it a bit.
Also, the op context destructor appears to have been using a fair amount. It looks like we must be creating and destroying vectors. Let's see. Let's see. Okay, so we create one for every do-op call. Do proxy, right? We create one. We're kind of creating them in a lot of places. So what happens when we create one, though? Because definitely destroying them seems to be costly. Now, anyway.
By the way, The profiling shows that on the read path we have significant overhead coming from frontend. We are not only bound by memory weighting, which is typical. We saw it in RocksDB. We saw it in OSD during write path. We are also constrained by frontend performance. With
Client
a lot of,
or
I mean, frontend of CPU.
oh, okay.
A lot of instruction cache misses, a lot of ITLB misses, and also very huge amount of micro ops delivered by a microsequencer, which is interesting, I would say. It might suggest that we are doing a lot of complex operations, like employing the machinery for dedicated for string processing in x86.
Yeah.
However, I cannot see a lot of rep instructions across the Ceph OSD code. And maybe there are in lib Ceph common or something like that, or another library. Still, the source is mystery to me.
Okay. It'd be interesting to see what you see once we I should commit this branch, and if you have time, try it out with all of these things ripped apart and just see how bad it still looks after getting rid of some of these.
Sure, with pleasure.
I would like to remind that the tests were performed on mobile processor, so these numbers might be different for this
Yes, that's true.
And they might be different for Xeons and other high-end desktop CPUs. So your mileage may vary.
Definitely. However, C states were disabled during that test. So, of course, it varies. It could vary with all. It could vary with processor, not even microarchitecture, even with model. Here, one CPU has 8 megabytes L3 cache, and we are fitting in. Another one has half of it, and we are lost. Who knows?
I think based on kind of what we're seeing, though, that almost right now seems like it's so kind of far away from where so much of our issues are, right? I mean, we have so many things that are going on. It's even hard to tell where it's, like you said, where it's coming from. I kind of feel like we need to strip all of this stuff away as best we can, and then kind of start adding it back in, and then very very methodically understanding how the different pieces of the OSD are kind of introducing different issues. I think we're starting to get there now, but it's there's so much that's going on, right? It's hard to narrow it down.
Yeah, and I guess it's a natural product of the development path we had of legacy. A couple years ago, there were the overhead of our debugging facilities wouldn't have matter. However, when we started targeting SSDs, crazy fast SSDs, wow, a lot changed. A lot of things changed.
Yeah, absolutely. I mean, a lot of this, in the hard disk days, or even hard disk days with SSD journals, didn't matter. It's now that we're really starting to chase these high performance deployments that that all of this now is kind of starting to really make a big difference. Yeah, there's so okay, ref counted object 6%, but 4.5% is just the destructor for MOSD op. And again, a destructor for vector. We're creating vectors there and destroying them. That's in the messenger thread.
Mm-hmm.
And objector op, and the destructor for op. Again, another 5% there. And again, vector destructor. Not as much, but a lot of time is spent in destructors. I should add a feature to this profiler to make it so that you can do things like just add up all of the time spent destructing things and show it.
You know, I wouldn't mind if it would let someone to do something reverse. I mean, take some function and display the reverse tree, from which places it was called and how many times.
Yes, that's a good idea. I think I originally had planned to do something like that, and then I got distracted and didn't do it. But it'd be very easy. All right. Well, I think the gist of all of this is that we've got a lot of stuff going on here. I wonder how often we really need to be doing making these temporary vectors or objects and doing stuff in them, if we can get away from that. Yeah, anyway, that's all I've got for this week. Radek or Adam or anyone else, anything anyone wants to talk about before we wrap up here? We've got like 20 minutes left if folks have anything they want to discuss.
No, I'm good so far.
Cool. All right. Well, we've got work to do. Yeah, go ahead.
Just one quick question. Do we have any vital reason for compiling and linking Ceph OSD as position-independent code? Actually, it's we have some overhead only because of that. Let me provide you with a link. Okay, got it. Basically, each call to function, just piece of code, regardless whether it's coming from shared library or our translation unit that is part of Ceph itself, has to go through PLT, which means one call and one jump. they are indirect. Basically, they are indirect jumps that are requiring resources from branch predictions and imposing unnecessary pressure on front end. Maybe cache misses, maybe something like that. But we are paying the cost. But is there a reason? Is there any good reason for that?
Assumption is that we needed it for something, right? And we just enabled it globally.
That could be the best.
I assume that's probably the answer, but I don't really know.
Adam is working on compiling Ceph without FPIC, so
Yeah, I'm trying to do that, and I succeed with compiling Ceph-OSD without FPIC, and I'm just trying to verify how performance looks, and I will do some prof sampling to look if we have better performance on our CPU. Currently, I just don't see much difference in IOPS, but it seems there is a bit less CPU usage for analogous amount of IOPS. So, but it's just I have it 5 minutes running now, so that's very fresh.
Was it hard to compile the Ceph-OSD without that?
No, not really. All the infrastructure is already there. It just needs tweaking with the global options to disable some globals, enable locals, and add dependencies for actually the pieces that are used for shared libraries, just to point them to be position independent code. Just nothing difficult.
Okay. I was gonna say I could give that a try with my tests as well, the ones that I'm doing.
I can share pull request right now.
Okay.
It should be working.
Yeah, I can try to apply it to my branch and see if it works. Let's take a look at what's changed here. Oh, that's not bad at all. That should apply pretty cleanly. Okay. Yeah. I can try it out, since right now this version of PetStore, I guess, is pretty good at uncovering CPU related issues, or at least it has been so far for me. Are you testing it just with like BlueStore on Incerta or something?
Yep.
I'm testing that on Incerta 7.
Sure. Okay.
BlueStore stuff on Incerta 7.
Yeah, it still probably will show it up pretty well.
Anyway, Mark, is the PetStore available?
It's in a branch. Yeah, absolutely. Honestly, it's nothing very special. It's really just memstore with like some tweaks plus a vector object. So it's nothing, it's
maybe
not
we should
impressive,
consider merging it as a dev tool.
Yeah, I was thinking about that. I mean, it would be really easy to implement the vector object in memstore itself, but the question is whether or not we want PetStore in. One of the things I want to do with it is make it a little bit more generic than just the memstore, because I want to add a on disk format for storing objects on disk, and also in I kind of want to transition away from how memstore works to have different object implementations and then different database implementations, including an in-memory database, so that it's it's not just like an in-memory object store. It's an object store that can store everything in memory or store things on disk and store things in like RocksDB or whatever. So I don't know if it, I don't know. Right now it's just the playground, but yeah, sure. Let me get you a link. Let's see. This doesn't include some of the the object, your stuff, your mdconfig t cacher or the ostring stream PR. This is just the stuff, the base one that I applied those things to. It's actually based on the new store revival branch that I had. So at some point this needs to be rebased and on master and everything, but you can at least see pet store in there, which is it's not very interesting. It's just like a mem store really, with some tweaks. The vector object implementation is here. It's really simple. It was a little surprising how easy it was to make. And it's much faster.
It's tiny.
Yeah, exactly. It's so much faster than the buffer list one. It's crazy. So yeah, if you're interested in giving it a try, it's pretty fast. The single finisher thread will probably be a bottleneck on insert, I imagine. So the next step here would be to make it so that it does multiple finisher threads like blue store or file store, and then at some point I want to make, like I said, I want to make it so that it can target the generic database interface, key value DB interface, and then make an in-memory key value database instead, so that you can kind of like mix and match both different kinds of object storage implementations and different kinds of database storage implementations. But that's what it is. So yeah, hopefully maybe you'll find it useful. I don't know. I did for this kind of stuff anyway.
Definitely, it could be very good tool for focusing on OSD performance, not object store, excluding object store.
Yeah. There's probably tweaks that could be done to make this faster too. It's really just a simple thing. All right. Well, yeah, I don't have anything else this week. Does anything else, guys?
Yeah, another thing.
Okay.
Can we use some underscore attributes underscore that are implemented solely in GCC without support for in CLang, but they provide some nice functionality? I mean here particularly the cold and the cold attribute, which allows you to request compiler to put some code far away from your hot path.
Yeah, I don't know. Maybe.
I guess that if anybody really needs that, we could get some very thin abstraction, just a few macro definitions to not harm CLang builds. So I don't know whether CLang is officially supported or not.
Yeah, don't know. No idea. talk to Sage, I guess.
Sure.
All right. Well, I guess that's probably it for today then. Other folks should be back next week, so we should have Josh and Greg and Sage back. So I guess until then, have a good week, guys, and see you next Thursday.
Thanks. See you. Bye.
All right.
Thanks. You guys.
See ya.